Alright guys, welcome to another video, and in this video we'll be looking at the last, not the last, but in the scope of the visualization libraries in Python that we want to look at. Plotly comes as the last one, which is a library that gives us more interactive feel with our data. Okay, so far we've looked at Matplotlib, we've looked at Seaborn, and I want to look at what? Plotly. So let's jump into the video. All right, so for Plotly, um Plotly, and we install, hold on, slow down, we import it as px. Okay, and it's just a high level interface, just the English. It allows you to create stunning interactive visualization with just a single line of code. All right, let's see if we're going to write a single line of code or we'll write more than one line. But the first thing we probably want to do is to import all libraries. So say import Plotly as px. Then we'll import Plotly dot graph object as geo. Then we'll import Plotly again dot subplots. Okay, no, this time we're importing from, you've probably seen the idea of this before when we're using, was it the math module or the random module, where we did from. So from Plotly import make subplots. Okay, so it's just majorly a family, then what you want to import. So that's the idea, simple idea. Of course, as usual, let's get our numpy and pandas. They might just come in handy. So far, let's just leave it. Let's run this. Now I want us to use the Titanic dataset in Seaborn. So we will be doing import Seaborn as SNS. Seaborn as SNS. Alright, so run that again. Okay, good. As usual, we'll just say df equals to what's the word now? SNS dot load dataset. Passing Titanic. How did we know we have Titanic? We already checked. To check, you can use to get the list of available datasets. Use dot get. Okay, let's say SNS dot get underscore dataset underscore names. All right. So, but we have done that before, so that's why we know. So let's check df.add to be sure everything is loaded. All right, nice. So you can see what we have in our data sets. We have survived class. This is a famous data set. Okay, if you don't know about it, you can take a quick look at it. You can do a describe. Okay, do a describe, do an info to find out. We have quite some null values. You can see none. So alive, yes or no, alone, true or false. Well, now in the one on cargo, because we have a version of it on cargo, there are some of the columns we have in here that we don't have in there. For example, we already have gender. sex, right? We still have woman, man, maybe children and all of that in there like that. So feel free to explore the data. We just want to write some line of code quickly for us to create what we want to create. Okay. So we can decide to do some cleaning up. Like I said, you can see some none, but let's check properly before we do some cleaning up. And say df dot is null. I'm using is null. You should probably familiar with it by now. And I said is null is the same thing as is any, right? So is null dot sum. So let's see. Okay, so I want to see now for the deck. We have about 688 null values. Survived, everything is complete. Age, we have 177 missing values. Embarked, we have just 2. Deck, we have this. So we might not necessarily use the deck. So we can just extract some that we want to use. But for now, let's do some cleaning up. Let's say clean up. Clean up. Before we do the cleanup, I want us to. This has so many unnecessary columns. I think we should just. I want us to use the one from cargo. So we'll just go ahead and search for it. So cargo data set. Cargo data sets. By the way, cargo is a place where you can get public data sets for free. So cargo data sets on Titanic. I think, and there's a particular one. I think data science dojo. So just grab it. I think it should be a link. I should be able to get a link from here. Code. Join notebooks found. Data. Okay. All right. This has been split already. Or is it from the GitHub? And there's the Titanic data sets. Code. So I just want us to get the URL. The URL of the data set. Alright. So let's just go back and use the URL. I think I'll put that somewhere here. Alright. Okay. So let me just do URL HTTPS. I think the one I remember is from GitHub, not necessarily. It's usually GitHub user content. .com first. I think that will follow by the repo, right? The person's repo. And master, which is the branch. And finally the name. So don't worry, I'll leave a description to the link in this comment section below, so you can just copy and paste it. You don't have to type it all the way out like this. Titanic.csv. Okay, so I'll change this to, we can then take out the imports. Of course, except to destroy the session, pandas is already available for us. And I'll take all of this out and do pd. Now I didn't import pandas, that was cbon. So let's do import pandas as pd. Let's just import numpy as well. Import numpy as np. So I'll do pandas.read underscore csv, and then I'll pass in the URL. Then let's check this way. But we want to connect, so we connect without any issue. I just hope there's no typo anywhere. There we go. Service not known. Okay, one thing is sure, I definitely have network. So yeah. So okay, the URL error. So okay, it's possible the raw option has been done with. GitHub user content.com. So is it still the same error we're getting? So okay, cannot open the URL. Well, let me just remove all of this first. Let's try this. Okay, let me just go and grab the actual name from somewhere. I don't know. But before I do any of that, github.contents.com. Okay, let me just undo it to see what we have before. Oh, okay. I think that should be dots. Bad requests. Okay, I'll copy this and then let's paste in here. Okay, so yeah, it's correct. So what did I miss? Let's just replace it. Probably there's a typo at some point. So just copy and replace. Oh, okay. If it's breaking to the next line, that probably means I missed something. So let's see. raw.github.com. Okay, data set. Okay, data set is what I missed. All right. Okay. So let's run this now. Good. All right, we're good to go. Okay, so now we have the data set, and okay, so we can see what we have: passengers ID, survived, P class, the names, the gender, the age, siblings or spouse, that's what that means, parent and children, the ticket, the fare, the cabin, and the point where they embarked. So we have Southampton, we have C, and I think there are about 3 right there. Okay, now that I've uploaded our data, we can do our is null again. It should still be the same. We should still have 177, just that new columns were created for that particular one. Okay, you can see we still have 177, and for the cabin, almost everything is missing, and for embark, it's still 2. It's still 2 as well. Okay, so let's do some cleanup. Cleanup will not be much. Just maybe do some mapping. Well, for example, we can say df dot survived. Okay, so df dot survived. I mean square bracket, not dot, obviously. Then we'll say that is df survived again. I'll take it from, oh, I thought it was showing from the bottom. Survived Then want to because if we look at the values we have in here for survived, it is not really explanatory. Survived 0, survived 1. Of course, this would be good for a machine learning project, but since we're not jumping into machine learning, we want this to be categorical, right? It should be died or survived. That's what we want. So zeros and ones, that's what we want to do. So we want to map zeros and one, or do we have any? How do we even check? What if we have other values in there? So we can do df dot group by, and then we'll pass in survived. So then we'll do survived dot value counts. Okay, so we have just zeros and one there. So these are the two figures that we want to map outside. So in this case, of course, you can use str dot replace, but that's a long way. We have a better option. We can just say map, which gives us a much more good flexibility. So we can just pass in a dictionary. Then we say 0. So for 0, that means they died. For 1, that means they survived. So before we run this, would there be any other cleaning we want to do? Would there be any other cleaning that we want to do? Okay, let's say for example the passengers class 3 1. Let's check the passengers class. We're just seeing 1 3. Of course, I know what is there, but it's a good way to check. P class, C. Okay, it's lowercase c. P class. So we have 1 2 3. So this first class, second class, and third class. So we want to replace that as well. I want to map it as df. Where's P class again? Is equals to df P class dot map and pass in the dictionary. We say 1. And just do it as first class. 2, and do it as second class. And 3, we'll say third class. All right. So we want to print the head again down here. df.head. Okay, you can now see we're now saying died, survived, and first class, second class, third class, like that. Okay, that makes more sense now. So before we jump into our charts, I want us to also set since we're using Plotly, so I want us to really explore some flexibility in Plotly. So we can set a template, or we can do some, what's it called, some styling option. So we can just say style up. Then we'll say, let's do, let me use capital, dark templates, templates. So say Plotly underscore dark. And for the next one, I'll say color sequence. Not that one, not that one. Thank you. I want to do color sequence myself. Color sequence. Then we'll pass in a list of some codes that already, of course, I know in my head. First one is 00 hashtag first. We have 00 E5FF. Yeah, I think so. Then we have FF FIA, yeah, FIA 00. Then we have code as well. We have FF1, I think 744. Is it 774? 744, yeah, I think so. And this we have 00E676. Yep. So just put that in quote as well. Okay. It's all good now. So this should give us the following colors. We have these as well. We should also have red and then green. All right. So we want the styles. So we'll just run that. Okay. So now that we have our style set as well, we can now jump into the visualizations. So for the bar chart, we can group first. So df bar, then we'll do df okay, we're just doing dot group by straight. So we want to group by passengers class and survivor. Okay, I think it's all lowercase. So we need extra square brackets. No, we don't. Survivor. Survived. Okay. Survived. Let's check again. So we have, yeah, these are the columns that we have. So survived. Then we want to do a group by. Oh, okay. Let's just do the size this time. Then dot reset index. Now passing name. Count. Okay. Let's see what df bar will look like. All right, nice. So this is what we get. We have the passengers class. Okay, for died and survived. So I was looking at it that this is repeated, but of course, we have for died and survived for each classes. So this is the data we want to work with. Now we want to plot this particular data, so we can say bar dot px. Now why are we saving it into a variable? Well, because we want to do some style updates on it later, so we just want to save it into a variable for now. So px dot bar, and then here we can say we'll pass in the data frame df bar x is equals to the p class, y equals to the count, color, let's use survived, what else? Now inside there is where we also declare our title. So you can see that it keeps getting better. Matplotlib, we had to do a lot of customization outside, but when we use Seaborn, things like X label, Y label came with it. Now this time we're getting to define our label inside our data, and the inside our as an argument, right? Now one of the cool things about this is also that we can use HTML tags. If you have basic knowledge of HTML tags, for example, let's say we want to make let's just type in the title first. Okay, so survived title, survived survival, this one survival distribution across p class. Okay, so we can pass in a variable that says color on argument, was it discrete map. Then for survived, this should be a dictionary. We just want to use keyword. So for survived, that would be 00E. That we use 676. And for perished or died, perished sounds cruel. We can say FF1744. Okay. What else are we supposed to pass in? Or what else can we pass in? Bar mode, say group, this group, and this can be on the same line. Don't need to put it on another line. Count. Am I seeing that funny red line there? I think everything should be okay. Perhaps you forgot a comma. Okay, so that is after. Okay, after this guy. I think I'm running into a lot of syntax error. So let me do bar.show. So we're gonna use Matplotlib as no attribute bar. Let's check that. Let me go back up. This cell was executed, right? As px. Let me just run it again. Then we'll come back. Plotly has no attribute bar. It does. Yeah, I'm 100% sure that we have Plotly variable for bar. So let's do something. import plotly as px. Okay, so that's taking too long too as well, but let's see what the output will be. Okay, that was fast. Yeah, so let me go back up. Okay. Dot express, right? So I imported it wrongly, so it was not imported at all. I just added this express now. Sorry about that. So I was 100 times sure we have in there. So let me take this out now. All right, so you can see how nice that is looking. We have red for dyed, and you can see the over effects. See a lot of zoom. We can zoom in. We can. Oh, this is so nice. All right, before we get carried away by the old fancy thing, let's let's add some more updates to this. So we can do bar dot update. Now you can see a lot of things that we can update: the layout, the maps, the annotations, a whole lot of stuff there. So I'll say updates traces. So I'll say text position, text position. See, okay. So I'll do position. Okay. So this should be inside. There's the inside. And then text template. Of course, you will need to go to visit the documentation of Plotly text templates, right? Yeah, I think that's correct. And single quotes. Then where's the percentage? We'll pass this in, then we'll do a text just like that. Okay. What else can we pass in? Can pass in selector. Dictionary. Then we'll say type equals to bar. What else? What else? What else? I think we're good. So let's update the layout as well. Bar dot updates layout. Update underscore layout. Open this up. Now this is where we can pass in our templates. Remember, we defined a template earlier. If you look at it, we did some color scheme. You can see. So template. Then we can say dark templates. So bar gap. Let's see. So say bar gap maybe 0.15. X-axis. Axis. Okay, that looks so strange to spell. So we'll say dictionary. I think I can bring this down. So that'll be dictionary. Title should be passenger class. Okay. So far this is what we have, and this is really nice, right? As you can see, I can overrun it. You can see survived, second class, count. So all of those features are there. You can see I can zoom in, I can zoom out, I can select. You see a lot of feature. You can scale, you can do so much with it. So feel free to explore. I also want to give you a good knowledge of the basics. So yes, we have reduced the bar gap. We have used our dark fill. If you don't like it, don't use it. So this is what we have now, and this is really cool. I mean, it's really cool. You can see we have everything the way it should be, and it's looking nicer than what we've been doing so far. All right, with just a line of code, of course. So let's move on to the line chart. So let's do a line chart. We want to see the cumulative fare. Now, when it's cumulative, we use area chart, right? So cumulative fare by the age progression, right? So you can just read all of these. They are there for you. So df line. What did we call this? I think the data set. Okay, df bar. Yeah. So we use df line. We just use that idea to keep everything consistent. So say df dot sort values by age. Then say df line cumulative fare this will be df line, then fare, of course this is feature engineering, we're creating a new column, then cumulative sum, sum. Okay, so we'll just do everything in a single line. Let's just do it here. I'll use Altenta, so create another cell for me. Then I can say line equals to px.area. Then we'll open this, we'll pass in df line, we'll pass in x as age, we'll pass in y as cumulate equal to cumulative fare, passing title cumulative, that'll be revenue, to bracket fare, just for clarity, by, that should be lowercase, by passenger age, progression. So what I'm trying to find out, the first one we looked at the number of people who survived by class, right? For red, that's died, right? We use colors intuitively, right? We use colors intuitively, and in this case, we want to see how much how they paid based on their ages, right? And it's cumulative, so we're using area chart. It's just a simple rule of charting or visualization technique. Let me use the word. So backslash. What else can we pass in? Color discrete sequence. Now passing, of course you don't need to do advanced customization. Starting out, you can just keep it simple, but because we have done matplotlib, we've done Seaborn, so let's go all the way in. The major things you probably want to do is this first two line. Of course, That's the point of learning. You might not know it by default, so that's what I'm showing you, so that you know you have the options to pass all of these values in here. So you can say line dot update traces. Then we're gonna do line equals to a dictionary of width equals to mode. Let's do line with markers. Should be plural, right? Yeah, I think so. Then we have marker. It should also be a dictionary. That'll be a dictionary of the size and let's say the display size. Let's just say 4. Then max displayed 20. What other arguments? Let's update our line.update layout as usual. Templates. So let's make sure our x-axis grid is not showing up. X-axis show grid. I will say that will be false. Okay. Show grid, right? That's correct. So we want to make sure our x-axis grid is not showing up, right? Then we'll finally say line dot show as usual. All right. So just a quick one before we execute this. Some of the attributes we used, for example, the mode, right? For example, the mode, this is just to force the chart, right? To get us the continuous lines and also the point markers, the pointer markers. That's for the mode. And for the show grid axis, I believe you already know that. What show grid axis does. Templates, of course, to just tell it that we're using the dark mode. What else? What else? Our line width to okay. We also have the discrete color sequence, and that just takes color. Let's say, for example, we have multiple series, right? So it just picks the color we're passing here, and then we assign individual values to it, one after the other, just like a list. Now, for example, let's say we have a pie chart. Let's say this is a pie chart, and we have a category, right? We have the category of, let's say, survived, where we have died and alive, or survived, died and survived. Or we say passengers class, first class, second class, and third class. So in this case, we just wanted to pick in the order we write it here. So say, for example, I pass in another one, and let's say, for example, I pass in another one. So it goes over the sequence one after the other, picks the first one for first class, second one for second class, and third one. So it just iterates over the list like that. What else? What else is here? Okay. For the max display, we're just restricting our plot to show a maximum of 20 markers at any time, at any one time, just 20 markers. So what plotly does that, it automatically hide markers if they are more than 20 points in the view, in the entire view, just to keep the visualization clean, right? That's the reason for that. So what else? What else? What else? I think we're good. Now, before we continue, I think we can change this color. We already have a color sequence, right? We created a list of color sequence, so we don't need to pass in this hexadecimal code, and I don't need to remember it again. So I can just check color. Okay, I think it's all caps, right? Color underscore sequence. Good. We'll run that, and so since this is what I want to pass, so I can just say color sequence. And of course, how do we access value? We access value using the square bracket. So I'm saying pick the first one, right? 0. So yeah, this is what we have. Let's run this. All right, so you can see what we have. We don't have our x-axis grid line. Everything looks nice. Dark mode. So it's all good. It's all good so far. You can over on it. Now for the over option, we can add more values to the over option, right? Let's say we want to see the class that they fall into. Now we don't need to dump all of those things into our visualization, so they can just be there when we hover on a particular point, right? And one beautiful thing about this is that we can also zoom in and zoom out, right? We can zoom in and zoom out. Say for example, I want to really understand what is going on in this part of my data, so I can just do something like this, and you can see it's going to zoom in to that part. I can zoom in even more, so you can see I can see different points in my data, and you have your controls at the top right here. Okay, so yes, that is that on line charts. The next thing we want to do is our donut charts. Okay, so for our donut charts, we just want to check the want to see the demographics of the passengers. I want to see demographics of the passengers. Uh, let's just write some code, but I think we need our color sequence so that we can pick a particular color. So I'll just print the color there. All right. So we can see as usual, donut. And we'll say that equals to px dot pi. Open the bracket. We'll pass in our data frame. The name will be the gender or the sex. What else do we want to pass in? Of course, title. Title. So let me check quickly. All right. So I've been using our tag. So just use our tag again in this case. So we title this gender demographics. So this is just an HTML tag to make it bold. So we want to pass in all. So say all should be 0.50. Because we want it as a donut, right? Do not forget that we're using pi. So we want a donut version of it. So we can pass in all. And yes, we can pass in our color, discrete sequence. Since it's not like we are not really specific about letting it match a color to another one, right? So you can just pass in the sequence option, color. The difference between the sequence and the map is basically the fact that for the word map, right, you want to actually match a specific color to a specific point, right? So in that case, you can map them. But if it's just a sequence, then it just goes over it, picks the first one, put the first one all the way like that. So yeah. For the colors, we want to pick the first color. So I'll say color sequence square bracket 0. That's the first in the list. And also I want to pick the second color. Second color, that will be 1. That will be 1. Okay. Now, as usual, let's do our formatting. So we'll say donut dot update. It's supposed to come up. Update layout. Okay. So update traces first. And then we'll say, take out the equal to, and we'll say text info. text info as percent plus label, and then we want a pool. Now let me just write all of it, and then we'll explain some of the main attributes we have. So 0.05, that should be okay, and then 0. So the first series will be pulled by this is it diameter or radius now, and then the other one remains the way it is. But you see it when I print it out to make more sense. Okay, why is this highlighted? Okay, yeah, this should be names. The red will not just, and just take it off my highs that is there. All right, so donut dot update layout donut dot update layout, and then we'll pass in our template. Then we'll say templates, oh, dark templates rather, dark templates. All right, that's all. And then we'll do donut dot show. Okay, yeah. What did he import? Okay, we'll pass in templates earlier. All right, so just before we run it, what are new? Do we have anything that is new? Okay, all is new. All, like I think I mentioned that already. It's just to make it create an all, yeah, an all, whatever it is, inside the pie chart, right? And we specify 0.5, so that's like 50% radius of all inside there. So it just does 50% radius of all. So for that, for the text info is just to configure the text label directly on the slices, right? To display both percentage, that's the category, percentage value, and the category name, that's percent and label. And for the pool is just meant to create. Now it's just like we want a slice to stand out. We know we are only getting male and female, so we want one of the slices to stand out. So it pulls it back out, like it pulls it a little bit out, right? So the right word is explode. We have it in Excel as well. So it explode one of majorly the first one. It explodes the first category because this is a list. So it just picks the first one and explodes it by 5% radius. Okay, it explodes by 5% radius. What other thing? Nothing else, I think. Let's just run it and see how nice that looks. All right, so you can see what this looks like now. This is showing, remember we said percent plus label. So we're getting the percentage and we're getting the label. You can see the colors that we have. Our colors are picked directly from the color sequence we already did above, right? Remember we have this list. So it's picking them nicely. And you can see the explosion by 5% radius. And the other one is just sitting where it is. So just to make it stand out, some cool styling that you can add. And our title says gender demographics. So everything is coming together so far, and I hope you're liking Plotly already compared to the statistical visualization, right? And the native Matplotlib, which is the foundation. They are cool, no doubt they are cool. But if you just want some more interactive view, right, you can go past Matplotlib, Seaborn, and then use Plotly. Okay. All right. Moving on to the next thing, histogram. Okay, want to create an histogram for just the age bin of the of the of the data, right? So first thing, as usual, we probably want to check our color sequence, just so when we want to use it, we know the colors we're picking. Color sequence, right? So color sequence. As usual, we'll call it east. I can write it histogram in full, but let's go with do east. Then we'll say px.histogram. Then we'll pass in our data frame, passing x-axis as age. In this case, we do not necessarily have axes in the pie chart, so we use names. So just trying to highlight the slight differences between the charts. Okay, so we use names, but here we have x-axis and the rest we have y-axis and all. So age, colors, color will be survived. Title, just put a simple title in there. Let's say age distribution. Age distribution. That's all. Next thing, we want to do the beans, number of beans. 25. This is 25. And then we'll do marginal. Then I'll say rog. What else? What else? What else? Okay, of course, our color. Discrete. In this case, let's use discrete map. And for that, that's a dictionary. So you can say survived. Survived will be color sequence. So let's pick the last one first. That's -1. And that's -1. And died. That's like the yellow or the green color now. So died. Color sequence. In this case, we want to use this, so it should be red and green. This particular one, so we can just do -2. All right. So this will give us -1. -1 will get us this. -2 will get us this. All right. So we're not done. We want to probably add some transparency. So see opacity, so that they are not the view is not blocking each other. So we can see 75%. And bar mode, we'll do an overlay. Okay. All right. So far we're good. Let's before we do is to show, let's update our layout as usual. Ist.update underscore layout. Template. Dark as usual. Of course, if you don't want a dark template, you don't have to pass that in. X-axis underscore title. Passenger's age or passenger ages, passenger's age, whatever. And then y-axis title. Y-axis title. That will be frequency. And then we can do ist.show. So is there anything we need to go over before we run it? Well, if anything at all, that should be the number of beans. Well, the number of beans is obvious. we're saying we should group our data into 25 equal groups or bins or intervals, right? So for the marginal, which is log, I think I left the comment here so I can remember the, how to what to know, what to remember to show you, right? As I just had those little text up there. So for the marginal log, or the marginal that is log, it's just it has a secondary log plot. Okay, that's just what it does. A secondary log plot visualization along the bottom, yeah, bottom margin. Along the bottom margin, it draws a small vertical ticks for every single individual. Is the same thing for every individual data point, right? That's what it does. To make more sense, once we execute the code and you see the visualization out there. So bar mode is just we forcing any overlapping bars, right, to stay or to sit directly on top of each other. And because we are doing this, we are what overlaying as well. I said we're overlaying. We are adding some transparency. So I think this should have been the front, but it doesn't matter anyway. So yes, that's what we have. Every other thing is explanatory. So run it and let's see what that looks like. Okay, you can see that the bars are now like over each other. So this is what we have so far. So we have an over. We can see individual what's it called, plots like that. The reason we had to do the overlay and all is because we're checking for survived and died in a single visualization. Remember, that's where we passed in this guy, right? That's where we passed in this guy. And of course, we now passed in the color map for individual ones right here. So if we don't want that, we can remove it and just have a single age distribution of both those who lived and those who died. Or better still, you can do this for, or you can do this as a as different plots, right? And so you can have the died separately and the survived separately as well. So anyway, let's demonstrate that so that I can see. All we're changing is just one thing anyway. So let me copy all of this. We don't even need to do too much. All we have to do is to pass in something we call facets column, and then we'll say that will be equals to survived. All right, so this alone is going to get us what we want. Then we'll put our comma in here. Now our title is still correct, but this is no longer needed. Let's just run this and see what it looks like first. Saving, so you can see now that we've been able to separate them differently, so we don't even need to change anything. So passengers age, both of them. So if we want it stacked on top of each other, we can change this to row. So you can see at the top. So yeah, this is what we have. We don't need the bar mode overlay in this case, so we can remove the bar mode overlay. Okay, so yeah, we have died, survived. We can add heights if we're using the row, and add heights if we want to, but I'll not be doing that. Oh, cool. Let me put this on top, so it should just be right above this. All right, everything looks good so far. So now you know how to separate them, but in the first version we stacked them on top of each other. All right, so now let's move on to the next thing. We want to create a waterfall chart. This will be quite some codes, but we'll just, as usual, go through what some of the key some of the key code we'll be writing would mean. Okay. First of all, before we can do anything, let's do our color sequence, run it just so we know color to pick. Okay, in here, we'll need some variables first. So say total passengers, and that'll just be length of our data frame. We also want total men who were dead, and that will be length of. Now in here we can pass in a condition, right? So we'll say df first, and in the square bracket we'll pass in the condition. So df, it will be two conditions, df into square bracket gender, single quote first, right? So if the sex is male, that's the first one, and the next condition would be, we also want to check the number of male who didn't survive, who died, right? So let's open another parenthesis, and then we'll do df, square bracket, survived, capital S, and get this first, survived equal died. This will get us the list of those men who died. Now, if we want to do for female or women who died, just copy this, paste here. Then we can change the variable name, women. Then this will be female. Okay. So we now have the number of men who died and women who died. So the next thing for us to do is we want to get the total number of people who survived. We want to get the total number of people who survived regardless of their gender. So say total survived. That will be the length of our data frame, df square bracket survived equal survived. Okay, so we have the total passengers, we have the number of men who died, number of women who died, or number of number of male who died, number of female who died, and the total number of people who survived. That means those who did not die at all. Let's just make sure this variable is available for use. Okay, now that our variables are available, we can now jump into creating the chart itself. Okay, so like I said, just write the code along with me, then we will explore some of the key parts of the code. So say waterfall as usual, then we'll say go dot figure. Inside there, we'll now declare what we want to do. Say go dot the actual waterfall. So waterfall, no, it is like this. Yeah, name equals to Titanic, orientation, vertical, measure. We're passing a list here. So relative, 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 and then total. Okay, total. And by the way, make sure you stick to the end of the video. I'll still show you properly how to write, how to use subplot with plotly itself, how to use the actual subplot with plotly itself. What am I saying red? Okay, let me type what I want to put in here. Then we'll say, so based on our variables, total passengers, that will be total boarded, right? So what's the next variable? The next variable is what? Male died, or male who died, no, male casualties, casualties. Then female casualty. Excuse me. Come here. I just jumping out. Female casualties. And then total survivors, right? So we have total passengers or total boarded, male casualty, female casualties, and then total survivors or survivors. Let's use survivors. All right. So the next thing we want to pass in is text. And then we want to do, using our f string again, we want to do a plus. Then we'll say total passengers, right? Then we want to do, oh my, why is it showing? Okay, I omitted the comma. All right, equal to, I mean. Okay, good. So total survivors, men died, I don't know, women died, was negative, women died, and finally total survived, total survived. Okay, so we have this for our text. Next thing we want to do is comma first. So we need a y, done for x. So for y, we'll pass in the actual values, and that will be total passengers, men died. Show up, please. Men died, women died, and just put this as 0. So next, we want to do decreasing. Equals to, now in your putting marker, that will be dictionary of color, which will be, so for the decreasing value, that means, for example, those who died, right? Those who died will be a negative value. That's red. That's minus, right? So for the decreasing or the negative value, we want to do our color sequence of I think the last one, no, the sky. This is our red, so we'll do -2. Then I can just copy all of this. Let me add a comma first. Copy all of this. Okay, I'll copy this way and paste this way. All right. So yeah, we'll change it to increasing, increasing, and then the color will be the first one. Okay. And finally, we want our totals. Okay, let me just paste that again. Undo. Totals. Then the color will be -1. So the last one is all we want. All right. So this is this for the first part of our waterfall. The next thing for us to do now is to update our layout as usual. So we'll say waterfall, waterfall dot update layout title equals a single quote first. Okay. So we can say sequential passenger accretion. Should we say cumulative? Yeah, cumulative. Cumulative. Alright, let's just do it this way. Do a comma. Tag template. And we don't want our y-axis grid to show. So y-axis show grid. Equals to false. Okay, that seems like we're good. Oops. All right, waterfall dot show. Okay, let's see. Okay, before we run it, let's just look at what some key part of it would mean that you might not understand. So the measure basically is about, of course, do not forget the order of our variables, right? Like this, like this, like this, and that was the way we pass them in as well, right? That was the way we pass them into this place. So for the measure is just to tell Plotly how each step will calculate its value. So when we say how each step will calculate its value, it simply means for relative, it adds or subtracts from the running total. When we say running total, right? So it adds from or subtracts from the running total. That means based on the previous value, it keeps adding or subtracting from that one in simple English, right? While the total itself, right, the last total you are seeing there will force the bar to be calculated, to calculate the sum total from scratch, from the baseline. That's just the idea of what that is doing. What else do we have there? So the decreasing and increasing, they're just key value, right? They're just key value for colors. So negative color, positive color. That's also what we're doing. So if it's a negative value, you should take this color. If it's a positive value, you should take this color. You can see that when we pass the list, we said this should be a subtraction, right? So it subtracts this from this running total. Don't forget. So that's what we have. That's why we passed our y-axis in that particular manner. So what else? Do we have anything else to say? Also, no, nothing. Pretty much nothing. I think now you have a good idea of what we have written. So we can now go ahead and run the code. Let's see what it's going to look like. Maybe when you see it, you'll be able to make more sense out of it. Was that executed? Okay, still running. Taking long most times. It's not good. All right, so exactly good. Now you can see what we have and see how nice it is. So at the first instance, we have the value to be what? 981. Then after that subtraction, it was minus this total value. Then that means we have 468 men who died. Remember, we have men who died first, and then 81 minus 81 women who died, and then people who survived are just 324. You can see total boarded, male casualties, female casualties, total survival. So you can see it that way, and you can see the icon, right? So see, pay attention to this little icon beside the numbers. After total boarded 891, we see all the total values. Then we see 891. The arrow in front is pointing upwards, so everything is still good, right? Then at this point, if you look at it, at this point, it's a male casualties 423, and then the arrow is now pointing downwards. That's a negative, right? If we come here, you can see 81 is pointing downwards as well, and this last one, you can see we're not having any direction anymore. It's just that's the end. So we're saying these are the number of people who survived. So you can see how the initial value all the way down to the end. So yeah, you can see what the features of Plotly look like and how interesting it is, right? You can see how interesting it is. So how many do we have left? Oh, just two. So we are just at the very end of what we are doing. The next thing we want to do now is to do a scatter plot, right? And as usual, let's just check our color. Just check our color sequence. All right, so our color sequence is here. And the first thing we want to do is, as usual, scatter. Call it scatter, and then we'll say px.scatter. Passing our data frame, x-axis as the age. Don't forget, this is the idea of what we want to do: age versus the fair and class. So say also we want color to be survived. Then the next thing is to do the size. Size should be determined by the fair. Why? Oh, okay. Quotes. Let's start the quotes. So size, and then we'll pass in one of the things we've not used before, over data. And as it sounds, it's just what it means. Oh, the sound is the same thing it means. How do I put that? You'll find out later. Embarked. Nope, not like that. Outside, the comma should be outside. Okay, so the next thing is our title. Passing our title, then make it bold. So far I've been doing that, so yeah. So we can see correlation, then we can see ticket costs versus age. Then passing, because we are using survived as the colors, right? Let me take that out. So because we're using survived, we're using color as survived. I'm just doing two things together. Remember, in the case of our histogram, right? So in the case of the histogram, right, when we did the two together. So in this case as well, we'll pass in a color map, a color discrete map, not sequence. Okay, so passing a color discrete, sure, please, discrete map. Then we'll say survived. Okay, from our color sequence, we can see that that will be show up. That will be the survived -1 because that's green. And then the last one itself, which is red, will be died. That will be -2. Color sequence -2. Okay, so we have been able to mark the colors. Now, we don't just want to stop there. We want to remove noise, right? Because eventually, when we plot this thing, let's just run this first. Okay, let's run it first so that it will make sense. So let's do scatter.show. Scatter.show. Okay, so you can see what we have. You can see what we have so far. Now we want to be able to tighten things up and cut out where we have noise in this data. I want to cut out where we have noise in this data. And of course, as usual, our title is that we want our dark mode feel as we have always done it. So let's go back up and say scatter dot update underscore layout. Now say template. Why is it importing template again? Dark templates, comma. So let's take out this guy at the top. And then we'll do to cut out the noise. Right, if you look at all of this, we'll say y dot dict. Then we'll say we want it from the range of -100 or -10, I mean, all the way down to 300. So put it in a range, a list range like that. Okay, so let me see what else we might need to adjust. All right, so let's execute this and see what we get. Then we'll go over our key parts. Okay, so it says, do you mean geo? Do you mean geo? Okay, that's a lot of, let me see. Probably have typo somewhere. Okay, scatter dot update layout. Okay, can convert update object to a tuple. Y. Oh, okay. Y axis is what we're working on. The y-axis. Okay. Now this good. Okay, that is running. Okay, so let's see what that looks like now. We have been able to cut out. We just want to see within this range from 300 all the way down to the negative side. So I know what you're thinking. Can we what about we do row uh facet column survived, and you see with comma, so you can see that it has been able to split the visualization for us just like that. So in case you don't want it stacked on each other, you can view it separately. I think I'll just copy all of these into another column. So I'll remove this. For the first one, we just want it in a single view, which is what we have loading. Okay, then we'll do code, we'll pass this in, then we'll see this. All right, so this looks better. So we have the died, we have the survived. So we're looking at the correlation between the ticket amount and the age. So what kind of correlation do you think this is? Is it a positive correlation, a negative correlation, or there is no correlation at all? So think about that for a moment and answer the question. But just before we move into the last one that we have, we didn't go over some key things here. So for the size, said it should be the fair. So we're saying it should scale individual circle based on the numerical value, based on the figure of the based on the size of the fair, of the figure of the fair, right? So you can see the bigger the circle, the higher the fair. So that's just what that is doing. And we also have over data. Consider this as what we can see in our tooltip without necessarily passing it for plotting. We don't want to pass it for plotting. For plotting, we only want it to appear in the tooltip. That means when we hover, right, this thing moving around with me with some this box with some information, that is our tooltip, right? And that's what we're passing over into the over class. Title, well, you know what the title is, an x-axis. I think every other thing has been explained. X-axis, so we can either determine the title or x-axis of editing itself. So we're saying we're cropping. Earlier when we didn't pass in anything, when we didn't pass in the x-axis, we're saying the fare up to about 800. But in this case, based on this, we said we just want to do a maximum of $300. We want to see between the range of -10 and $300, so that we can quote or technically quote and unquote exclude extreme outliers, right? That's just the idea of that. So yeah, we have been able to do a scatter plot with our pie plots or plotly, I mean. So the last thing we want to do now is the tree map, right? Which is, of course, you already know what tree map is, or how I will assume you know what a tree map is. So let's just do some what's it called quickly. Let's do df.count equals to 1. Then we'll say tree map is equals to px.treemap open, passing the data frame, passing the path, and here we want to pass in embarked, also pass in passengers class, then want to pass in survived, then want to do values, the count, right, this guy right here, so the count. Don't want to do a title, okay, we can just title this hierarchical hierarchical. Now that looks odd. Okay, so it should be hierarchy. Yeah, I think this is correct. Hierarchical breakdown. Now we say embarked ports. That's where they embarked on the journey. Um, ticket level or ticket tier, and finally survival status. Okay, so survival status. Then another thing. I think we're good like this. All right, color will be passengers class. Then we'll do a color continuous scale, right? Is it? Yeah, I think it's continuous scale. Color continuous scale, and then we have px dot colors plural sequential. Okay, sequential dot electric. All right. So finally, we want to do tree map as usual. Tree map dot update. Okay, tree map dot update. And that's called layout. Then we'll do a template. Show up. Then we'll do dark. It's not showing up, so let's do that template. All right. Now we can do tree map dot that's dot show. All right. So we have tree. What's the issue? Okay. So we have tree map dot show. Before we run this, let's just run through what some of these things will do or what they mean. So first of all, the path. Now in this case, the path is what define the hierarchy structure, right? Do not forget that Treemap is about is an hierarchical visualization. So the path defines the hierarchical structure. As in this case, since it's a list, so it goes right one after the other. Embarked will be on the level 1. P class will be on level 2, and survived will be on level 3. Okay. Now what else do we have there? Value, right? We have the value. For the value counts, or for the counts that we have here, we have it as what determines the area, right, of each rectangle. That's what we have. It determines the area of each rectangle. because I already set df to 1. If you look at it, df count equals to 1. So the fact that we made df count of 1 will mean that every row will contain equal every passenger row counts equally, no contain, sorry, counts equally, which means that the size will reflect the sizes of the boxes we'll be seeing, or the shapes we'll be seeing, will reflect the pure volume of each passenger. All right, the pure volume. That means the more passengers we have, the bigger the the what's it called will be, the shapes will be. Okay. So for passenger class, of course, we have used passenger class before. It's just to detect how the colors, how they will appear. So that means the inner. Now, in simple terms, let me put it this way: since we are targeting, excuse me, since we are targeting the uh, middle column, right, the middle one, which is P class. This is what we're targeting because this is what we pass as color P class. So since we're passing P class, that means all inner rectangle, all inner children rectangles, right? They will inherit and share their parents' color attributes. That's what it means. We're targeting this, so that means all inner children will just inherit which is the survival state, will inherit and share their parents' color attributes. So yeah, that's that about that. Is there any other thing? Is there any other thing? Okay, this is the first time we're using a continuous color scale. So now, because our P class, though we change by default, our P class is by default, as initially it is 1, 2, 3, right? So the idea is to just let Plotly apply a smooth continuous gradient, right? Now it allows it apply a continuous smooth gradient, and the electric is just a theme, right? It's a theme, and it's more like a transition between dark to what's this color now? Between dark to bright is a neon now, yeah, something like that. Let's say typically like dark blue, purple, or to like bright yellow. So yeah, that's what that is, and for the rest, you probably know what it is. So let's just execute these and see what we have. Okay, so what's the issue? But received a marked. Oh right, that means I accidentally typed this where I'm supposed to type. So if okay, marked, look at it here. So the path marked, I omitted the P, or a B, I mean. So we'll run that again. Alright, so it says non-entries cannot have not non-children embarked now. Alright, it seems in our embarked we have some missing values. Probably we didn't undo all that part as well. Probably didn't have it in mind. We'll use it. So let's see. df.embarked embarked dot is null, or is any. Okay, so let's see. We have 4 false. Okay, let's just add it up because we're seeing false. Let's do dot sum. We're seeing all false, so do dot sum. Then we'll run this again. Okay, so we have two none in there. So what does it look like? So we know what to fill in there. So if we do df embarked, let's print it out. Okay, so we have S and C, SCQ, right? We have SCQ. So if we do SCQ embarked, if we say we group by dot group by dot group by embarked, now we say dot value count. Okay, so let's see what this looks like. Group. Okay, group by. Let me add the by. So that looks like now. Okay, so the mode is S, right? That's Southam. So since the mode is S, we can just replace the two missing values with S. We want to replace with the mode. That's the idea. So we just say df embarked, right, dot fill na. I will say S. I will say in place equals to true. Let's run that. My spelling of embarked again. I'm missing the B. All right. Okay, so that is done. We're not supposed to have any missing value again. So this says 2. So let's see after we have replaced the missing value. It should be 0 this time. All right, so it's now 0. So we can now rerun this and see what we get. Okay, still loading. All right, so you can see what we now have so far. Let's see what we have. So for the third class, those who died, those who survived. For the second class, those who died, those who survived. For the first class, those who died, those who survived. So we have the 3. Now remember, embarkation points, if we have a word like that, is the outer or the first level, followed by what? The passengers class. So first, second, third, first, second, third, first, second, third. Then finally, inside there we have what? Survived, which is died or survived, died or survived, died or survived. Now remember that we targeted the passengers class. So we said if we target the passengers class, it's going to inherit the color of the parents. So this is why we have both colors the same. This is blue, both colors the same. This is red, both colors the same as well, right? So that is that about Treemap. And with this, I think we've come to a conclusion on Plotly for visualization. It's a long it's been a long drive, if we can say it's a drive. And up next will be a major project for you to do so that you can apply all the concepts of what you've learned so far. So for that and more, I'll see you on the next one. Do not forget the next one will be projects where you'll be able to explore. You can see it right here, but that will be in a separate video. So if you need to go over this again, write all the codes out, test it out, pick a random data set inside Seaborn, and you can use it to carry out some more visualizations for yourself. So for that and more, keep practicing, and keep practicing.